All right. Good afternoon, beautiful people. Today we're going to take some questions as always. And if you're not sure how to start your question, you can read one of these 5 questions. How would you do a question like this? For example, some of you are having trouble getting really high scores on USA Test Prep. So this will be a good chance to kind of look at those questions that you were missing. Or domains that you were missing, find a question from that domain, and then ask me how to solve a question like that. Yeah, I'm going to give a few minutes for some questions to trickle in while I get my chat up on my, there it is, finally, yay. Okay, so talking to one student about her current progress with the Unit 2 assessment on USA Test Prep. We kind of went back, looked at her test, and saw a pattern of error or a pattern of confusion. So I want to take a look at what's confusing her, and if it's confusing her, it's probably confusing a number of you. What is a function? I think typically students are a little bit confused about the differences between functions and equations and that kind of thing. You have learned about functions since 6th grade for certain, probably before that, but I'm not sure about elementary school standards the same way I am about the middle school math standards. But again, you cover so much math in a particular year that it's hard to keep track of it all. Let's first take a look at an easier question. What is an equation? So if we had y equals 2x, I think we would all know for sure, yeah, that's an equation. We have an equal sign, we have an expression equaling another expression, an expression equaling another expression. That is what an equation is. We could also have something like 2x equals 18. That, of course, we know is an equation. And often when we see this, our knee-jerk reaction is to solve for x, right? Because often in algebra or in middle school mathematics, when you saw a one-step equation like this, the reason they called it a one-step equation is that they wanted you to solve for x, okay? But essentially, you'll notice that 2x equals y is very similar to 2x equals 18, all right? They both have equal signs, they both have an expression, and this expression is exactly the same. Here is a y variable that can change. Here's a value, a constant that's always 18. Now let's take a look at something like this. And again, if you remember from our semester, this is read f of x equals 2x. This is an f times x equals 2x. F of x. F of x, this is just a function notation for y equals 2x. These are the same thing. Some people might argue that these are the same thing. Certainly they're related. But these, although they look different, are exactly the same thing. This is in what we would call more or less standard notation. It's certainly in what we would call standard form and even slope-intercept form, although there is no written y-intercept. This f of x is what we would call written in function notation, okay? It's sort of like this is my name. Oh, maybe I'll write it down here so you can see it. Jessica Wise. That's my name in print notation. But this, Jessica Wise, sorry, it looks a bit messy. Oh, forgot my E. Is the same words, it's the same name, but this is written in cursive notation. So standard notation, y equals 2x, f of x equals 2x, they're just more, they're just different ways of writing the same thing. So that is a simple explanation of a function. Now, there are reasons that certain equations or situations don't represent functions, but that is not of interest today. Okay, what's of interest today is matching, okay, matching a linear function to a let's fix that. To a table or graph. The EOC, of course, would not just have you match linear functions to tables or graphs. They'd also have you match linear functions to word problems. That wasn't presenting as a challenge for the students on USA Test Prep, so we'll just focus on tables and graphs. All right, first let's start with something like this. If we wanted the function f of x equals 2x, can we imagine what that table would be looking like? Can we imagine what a graph of that would look like? I'm going to give you a few seconds, minutes to try it out and think about it, and I will queue up some photos for us to use in a minute. Of course, if you want help on something different, you can also use this time to set up a question you would like me to answer. Okay. Before we start looking at those examples that you can find too on Khan Academy, if you Googled matching functions on Khan Academy, and it would give you not only videos to watch, but also practice. If I remember, I'll put a link to it in the description below. So 2x, I think the way a lot of us learn to graph first in middle school, and certainly how we have graphed some this year, was to create tables, okay? Now, typically you would see tables X and Y, and that's certainly okay. I just want to make a special note that you could have this say Y over here, or some formats might have F of X. And again, this is maybe the print way of writing Y. This is the cursive way of writing Y. Standard notation versus function notation. So if we have, let's start with 0. If x is 0, what is this function going to equal if x is 0? Well, the function is 2 times 0, and 2 times 0 is 0. We're going to keep going up by ones because that's convenient, but you could choose other numbers to go up by, but we're going to go stick with the 1 here. 2 times 1 is 2. 2 times 2 is 4. 3 times 2 is 6. Now we've made a table, so now we can make a graph. Okay. Of course, this is our y-axis, our x-axis. we're going to have is point at 0, 0. And I'm going to do, I guess I could say a graph is the picture of what x and y are doing when they get together. So when x is at 0, y is at 0, or the function is at 0. When x is at 1, the function, or y, is at 2. When x is at 2, the function, or y, they meet at this point right here. Okay, kind of they meet in the middle. Y is chilling up here on this line, x is down here on this line, yay, they meet at that point. They have that point in common. 1, 2, 3. When x is 3, the function is at 6. Okay, so we could then use a straight edge ruler, and I think, you can see I kind of eyeballed this graph, so some of them are not exactly in line. But there's our function. That's a graph of our function. It's a linear function because look, it's a line. And again, these are just coordinate pairs. 3, 6 is an ordered pair. 2, 4 is an ordered pair. 1, 2 is an ordered pair. And 0, 0 is an ordered pair. Now, occasionally on assessments, you'll be asked to use the function to create a table or use the function to create a graph. And that was mostly what you did in middle school. But in algebra, we're often doing it the reverse. You'll be given a graph, you'll be given a table, and you have to figure out what the function is. You might be asked, what table or graph matches this function? Or which function would make this graph or table true? Things like that. All right, so let's say our starting point wasn't 2x. Our function, our equation, our expression, we didn't have that as a starting point to make a table, to make a graph. Instead, we had a table as our starting point. With lines, and again, Unit 2 on USA Test Prep is just about lines, we want to remember that there are 2 points of interest for a line, right? We know that lines are written as this: y, or again, f of x, equals mx, m being the slope, plus b. I'm sure some of y'all are thinking that or saying that right along with me. This b is always the y-intercept, which is written at x is 0 and y is some number y. So the first thing I do when I'm looking at a graph or looking at a table to see which equation or function matches it is I'm looking for what is y when x is 0. Here we can see, I erased my x's and my y's, I'm so sorry. When x is 0, y is 0. Okay? In other words, y is 0. And that's this point here, that ordered pair there, and this ordered pair here. And that means if I wanted to write the function or write the equation for my b, or my y-intercept, I'm going to have this green number. I'm going to have 0 because y is 0 on the y-intercept, on the y-axis. The next thing I'm going to look for is my slope. I think we'll start with a graph because I think most of us understand finding the slope of a graph from a graph easier. In middle school, you learned about making triangles. We learned some additional stuff this year, or we reviewed some additional stuff, and we'll talk about both of those. First, you can do it the triangle method. Remember, we're trying to find slope, okay, which is the change in y, the rise, over the change in x, the run, okay? So that means we're always going to read a graph from left to right, but we're going to start by going up or down first. So here, to go from this point to this point, we're going to go up. 1, 2. So that means our change in y, change in y equals 2. And then from this point, we're going to go over. We're going to count how many times we go over. 1, okay? So that means our change in x is 1. We would simplify that, and our slope is 2. Now again, that tells us we're going to have an x up here. We'll always have, if this is a linear function, we'll always have an x. You can have plus or minus. This number could be positive or negative. And then we're going to have, if our triangle situation, our triangle method is right, then our formula is going to be 2x plus 0. And of course, we don't need that 0, right? Mathematicians would simply erase that. Okay, but let's double check our graphing triangle method by using another table method. What we do first, again, we're thinking about change in y over change in x. So the first thing we're going to do is look at how y is changing. We notice between 0 and 2 what's happening. Is it going up, going down, adding, subtracting? Of course, it's adding 2. Between 2 and 4, is it adding or subtracting? Right, we all know it's adding. And then it's adding 2. We notice that, again, adding 2. So that means our change in y is positive 2, adding 2 each time. We do the same thing over here with x, change of x, but we put our change in x, our run, on the bottom. Adding 1, adding 1, adding 1. So again, 2 over 1. Again, we simplify it to 2. And then mathematicians, they don't like to write extraneous numbers. The same thing in English, right? They'd say you're being redundant, right? Nobody needs to have a plus 0 there because that empty space means the same thing. All right, so that's kind of a breakdown of how this works. Again, you could also use the slope formula where you know these are points, and the slope formula is always y2 minus y1 over x2 minus x1. If you'd like a video about that, just message me down in the comments or mention it in the chat, and I'll make a video that explains how to do it that way. Okay, let us take a look now at a table example from Khan Academy. Let me make this bigger. All right, so we have a rule, y equals x minus 4. And again, you could call it a rule. Certainly they do in middle school. You could call it an equation, y equals x minus 4. You can also call it a function, although this is not written in function notation. And they, again, want us to create the table. And we would say, okay, here they want us to backwards design it. So essentially, what they're asking us to do is say y equals 6, 6 equals x minus 4, solve for x. I don't feel like doing that, y'all. So I'm going to kind of modify this question. All right. And you guys tell me if I succeed in modifying it in a way that makes this rule true. Okay, I'm going to make 2 versions of a table. And your job is to figure out which of these tables follows this rule. Okay. All right, so here are the tables I've created for you. And again, I would suggest, again, you could use the slope formula y2 minus y1 over x2 minus x1. But you could also simply look at your intercepts, things like that. We know that our y-intercept for the rule is -4. But do you notice how none of these tell us what y is? I mean, excuse me, what y would be at when x equals 0, because none of these values say x is 0. So that means we can't use the y-intercept of -4 to help us eliminate one of these two choices. What we can do, though, is use the slope. Slope, again, is always expressed as mx plus b. It's the m in mx plus b. In other words, it's the coefficient or number in front of x. In this case, the number in front of x is a 1. And again, it's not written because 1 is redundant. X means there's one x. But we're looking for a situation in which the change in y over the change in x for these is going to be 1. So first, let's take a look at this and this. And you don't write with the slope formula, we only needed 2 points. Here, let's just take 2 points, okay? What is the difference between 6 and 0? Are we adding or subtracting? Obviously, our 0 is getting lower, so we are subtracting. And we have subtracted 6, -6. Here, same thing. We've gone down 6 units, or we've subtracted 6. Now we need to look at the x values and see what they're doing. We're looking at 10 going down or changing to 9. Again, that's subtraction because 9 is less than 10. We subtracted 1. Here we've subtracted 6, right? So this one, if we look at the change in y over the change in x, we have a -6 over a -6. This one we have change in y over change in x. Sorry, I didn't mention in this video, we mentioned it in class. This triangle's name is delta, which is just a fancy short way of saying, like the nickname for saying change in, okay? Change in y was -6. The change in x was -1. And if we look at what these simplify to, only one of these, right, would simplify to 1. And that's the slope we're looking for. So, of course, A is the answer of the table that would make this rule or function true. All right, now let's take a look at some graphs. Here's a graph again. This is a Khan Academy activity. They've given us the multiple choice already. Which rule describes the relationship between x and y coordinates on the following graph? The EOC or USA Test Prep may say which equation matches the graph, which function is represented by the graph, something like that. So again, we're going to be looking for 2 points of interest. We're going to look for the y-intercept. We're going to look for the slope. I'm going to start with y-intercept because it's often the easiest thing to see. And again, as we all know from the semester, y-intercept is the point on the function or on the line where your line or function intersects with the y-axis, the axis that is vertical. And here we see a blue point at 0, 2, which means that the y-intercept is 2. Looking at our answers below, which of those functions or rules has a y-intercept of 2? We have A, y equals 3x, B, y equals 2x plus 2. That plus 2 means that's our y-intercept. And again, if you weren't sure, you could use substitution to check your answer. So for example, if I put in a 0 into A, y equals 3 times 0, I would get 0. And that would mean that this line needs to have a point at 0, 0, and it doesn't. Whereas B, y equals 2x plus 2, if I substituted 0 in that equation, 2 times 0 would be 0, plus 2 would be 2. And again, I know my answer is correct. Okay, the last example we'll look at together before I let you guys think of some questions is this question. Which graph represents x, y pairs that make the equation y equals x plus 3 true? And again, we're looking for 2 points of interest. Y-intercept, also known as B, also known as the place on the graph where the line or coordinate pairs intersects the y-axis. You know, there's lots of names for it. And the second one is slope. All right, so here again, I'm going to always start with my y-intercept. My y-intercept, or b, is +3 in the equation. So that means I'm going to look at my graph, and I'm going to be looking for 2 points on my graph. Excuse me, 1 point on the graph, but it goes by 2 names. The place on the graph where x is 0, the place on the graph where it intersects the y-axis. Okay, this one has we don't see an intercept, right? There's no blue dot on the y-axis, but you can see a line is forming, so it would hit the y-axis at some point. But do you notice how the blue dot is already at y = 3? Right, it's at 1, 3. So that means we can't have 2 points on a line that would have y = 3, not in this line anyway, because it would be right next to this one, and that would make this not a linear function. Okay, so let us go. Excuse you, Mr. Pitcher. There we go. Okay, I'm trying to see if I can just pick it up. All right, there we go. Okay, now this one, we're trying to find one that's x + 3. Here, b, again, we don't see a value on the function, on the graph, on the y-axis. So let's see if we can count out c, because it does have a point on the y-axis. But the point is at 1, so 0, 1. But we're looking for 0, 3, so that will not work. Unlike our first one, our blue dot example, this one doesn't already have an orange point at y = 3, which would be this line underneath the 4. But if I were to put my finger right there or my cursor right there, I would notice that it's going to be in a line with those numbers. So that means that b is the graph that would match the equation, function, or rule x + 3. Okay? The other thing you could do is, you see this point here is 2, 5. You could simply look at your rule or equation. Come back here, you. X + 3, and is 2 + 3 5? Yes, it is. So again, you could use the equation to check itself against a graph. All right, so those are some helpful ways to make sure a linear function maps. So beautiful people, I think I'm going to let you go today. Good luck with everything. Again, final grades and final work is due by May 6th, so that teachers can work on final grades. Okay, feel free to email me a message on Schoology. This is my last live stream, but if you have a specific math-related question about USA Test Prep, then of course I'll make a video in my spare time and post it to YouTube. But this will be the last interactive live stream for this school year, and hopefully for all school years to come. Hopefully we can stay in the building in a safe way in the future. Okay? Have a blessed day. Bye-bye.